This is section 5.2, multiplying and dividing rational expressions, and we're going to be doing a fair amount of factoring. So if you're rusty on that, you will not be for long. We're going to be simplifying rational expressions and multiplying and dividing. Why did the doctor send the expression to a psychiatrist? Because it wasn't rational. That wasn't too bad. Rational expressions, ration means ratio, something divided. So a rational expression would be something like x, oh, that's weird. X plus 7 over 2x minus 3. So a rational expression has a polynomial. These are both polynomials, so it's a quotient of two polynomials. That's better. Oh, there it is. Okay, next. Example 1, we're going to simplify. So we start off with one that all we can really simplify, the 3 over 2 is not going to reduce, but x to the 7th over x to the 4th will reduce. And so the 3 will still be on top, the 2 will still be on bottom. And then when you divide exponents, you subtract the exponent, so 7 minus 4 is 3, so it's x to the 3rd, and that's going to be up on top. If you're not sure if it's on top or bottom, you could also think about it as you have 7 x's on top. 1, 2, 3, 4, 5, 6, 7. They're all being multiplied. And on bottom you have 4 x's being multiplied together. And these 4 x's on bottom are going to cancel with 4 of the x's on top. So you're left with 3 x's and they're on top. So that first one is simplified. And the other thing you have to notice it says identify any x values for which the expression is undefined. And with rational expressions, the denominator is going to create sometimes places where it's undefined. So is there any value for x that you cannot have in the denominator? And the answer is yes, 0. So you would have to say x cannot equal 0. When you're checking to see where it's undefined, you need to look at the original expression, not the reduced one, because on this reduced one we don't have any x's in the denominator. You could plug 0 in here just fine and you would get an answer. But in the original one, if you plug 0 in for x, you're going to have a problem. So you need to look at the original one when you're identifying where the expression is undefined. Now let's tackle this next one. This one is going to require us to factor, because we cannot cancel terms. Terms are things that are added or subtracted. The 2x, the x squared and the x squared, those are terms. This one's being subtracted, it's being added to this negative 2x, this one's being added to the 5x. You cannot cancel these x's, these x squareds. That is not allowed. If you try it, it won't be equivalent to the original. So what we have to do is factor. We have a quadratic, and there's a 1 in front, so it's just xx, and then two numbers that multiply to negative 3 and add to negative 2 are negative 3 and positive 1. Same thing on the bottom, two sets, xx, and 4 and 1 will multiply to 4 and add to 5. Now, these factors are being multiplied, so they're no longer terms. This x plus 1, this whole thing is a chunk, and it can be cancelled with this x plus 1 on bottom. And then we're left with x minus 3 over x plus 4. And then we have to look to see where it's undefined, and you have to look in the original one. You don't want to look up here because it's hard to tell, but you want to look at this entire thing before we canceled, and look at the denominators. So in the denominator, what number in here would make this entire factor equal to 0? Because if this whole factor was 0, then I'll make this a big fat 0. If that whole thing was 0, you can't divide by 0. Well, if you're not sure, what you can do is make x plus 4 equal to 0 and solve. And that's going to be x equals negative 4. If you plugged in negative 4 here, negative 4 plus 4 is 0. Same thing over here, x plus 1 equals 0, x would equal negative 1. So, you would say x cannot equal -4 and -1. That's where this original expression is undefined. So notice you have to look at the entire denominator before we canceled and set each factor equal to 0 like I did here, and then solve, and that's going to give you the places where it's undefined. Please try these 3 on your own. It's really important that you try these on your own, and then I'll do them. So on this one, 16 and 8 will reduce. I'm going to rewrite it so I can work with it more easily. One thing you can do too is you can think when you cancel fractions, 8 will go into 8 once and 8 will go into 16 twice. So you can do it that way. And then here I have x squared on bottom and x to the 11th on top. 2 of these x's are going to cancel out with 2 of these. So I'm going to be left with 9 x's on top. So I still have a 2 on top, and I'm going to have x to the 9th on top. The other thing you can do is you can cancel that out, and you can cancel that out and write x to the 9th. Or you can think 11 minus 2 is 9, x to the 9th. And there is no longer anything in the denominator. This is undefined. You have to look at the original to see where it's undefined. If I have a 0 here on the denominator, that's going to cause it to be undefined. So x cannot equal 0. This next one's going to require us to factor. The numerator cannot be factored, so it's just 3x plus 4. The denominator, we have a 3 out front. We have choices on how we can factor this. Last semester, when we had a number out in front other than 1, I showed you how we could either guess and check, or you can use splitting the terms. So let's do it by guessing and checking and just see what happens. So I know that this one has to be 3x and this one can be x. And then you have to think of 2 numbers that multiply to -4. You could try -4 and +1, because those will multiply to give you -4. But then you have to check it and make sure it works. So you have to distribute it. So I'm going to have 3x squared plus 3x minus 4x minus 4. And that's going to give me 3x squared minus x minus 4. And if I look up here, it's supposed to be plus x. So what I'm going to do then is I'm going to go back and switch these signs. And that should do it. So you can distribute again. 3x squared minus 3x plus 4x minus 4. And then these are going to add to -1. Wait a minute, to positive x, which it should be right here. So that's the guess and check method. If you're good with numbers and good at mental math, it's a good way to go. It's faster than splitting the terms. But, okay, let's finish the problem. I'll do one over here where you use the other method, splitting the terms. Now the 3x plus 4s are going to cancel out. Be very careful when they cancel out. There is a 1 left up on top. So it's still 1 over, and then x minus 1 is down on bottom. And we're not done yet. We need to identify where it's undefined. So for that, you look in the denominator before you canceled, and you have to set these each equal to 0. So I have 3x plus 4 equals 0, and then I have x minus 1 equals 0. So I have to subtract 4. I have to divide by 3, and x equals -4/3. And this one's easier. I can just add 1. So that means that this function is not defined when x cannot equal -4/3 and 1. So here's the simplified answer, and here's where it's undefined. Get rid of that. These take a bit of doing. I'm going to need a lot of space, aren't I? Because I have to factor it. So we can do guess and check again on the top, or I'm going to actually show you how, let's do guess and check one more time, because this one might be easy to guess and check. So 6, I could do 2 times 3, or I could do 6 times 1. I'm going to try 2 times 3. And these are all pluses, so the last one could be 2 and 1, let's try that and see if that works. So I'm going to distribute that. I'm going to have 6x squared. I'm going to have plus 4x plus 3x plus 2. Hey, it worked. That's going to add to 7x. So I got it right the first time. See, it's not bad with numbers like that. But this one, let's do by splitting the terms. It's a long process, but it always works. And if you do it a lot, you get kind of fast at it. So on that one, what you do is you start by multiplying these together. 6 times negative 6 is negative 36. Then you bring down the 6x squared. You think of two numbers that multiply to negative 36 and add to negative 5. So that's going to be 9 and 4, because 9 minus 4 is 5. So 9x and 4x. And then we have to figure out our signs. One has to be positive, one has to be negative, and they have to add to negative 5. So that means the 9 has to be negative and the 4 has to be positive. And then bring down the negative 6, the minus 6. Then the next step is to factor by grouping. So we look at these and factor out the GCF. That's 3x. And then divide this by 3x and you get 2x. Divide this by 3x and you get minus 3. Plus, and then you look at these two and the GCF is 2. Remember, this plus sign always comes down. Divide each of those by 2 and you get 2x minus 3. Then you have 2x minus 3 and 2x minus 3, they match. So you're going to put those in a parenthesis and take them out front. And then you're left with 3x plus 2 as your other factor. I'm going to erase this and write my answer in here. 2x minus 3 and 3x plus 2. And then I'm going to erase all this work, get it out of the way. And now we can cancel common factors, so 3x plus 2 and 3x plus 2 cancel out. And then this is your answer. But we also have to find out where it's undefined. So to do that, we need to make each denominator equal to 0 and solve each factor in the denominator. So I'm going to be adding 3 to both sides. I'm going to be dividing by 2. This time I'm going to be subtracting 2 from both sides. I'm going to be dividing by 3. So that means x cannot equal 3/2 or negative 2/3. Because we do that before we cancel, because it has to be true for the original one. Example 2. So we're going to simplify. It's the same thing that we've been doing. So in the numerator, I see that we have a GCF of x. So I'm going to factor x out. And that's going to leave me with 2 minus x on top. On bottom, I have a quadratic polynomial that I can factor with x and x. And that's going to be negative 2 and positive 1. Okay, I don't have any perfectly matching factors. I have x minus 2 and I have 2 minus x. How are those different? Well, they're opposites of each other, which kind of gives me a hint. If they're opposite, that means one of them times negative 1 will equal the other one. So what I'm going to do is I'm going to factor negative 1 out of this top factor here. So I bring along my x. I'm going to take a negative 1 out, so I'm going to write negative out front, parenthesis. And what I'm doing is I'm dividing these by negative 1. So 2 divided by negative 1 is negative 2. And negative x divided by negative 1 is positive x. And the negative 1 that I factored out front, I wrote it as a negative out in front. And then the bottom I'm just going to bring along. Okay, now isn't this top factor the same as this one? Because it's commutative, addition is commutative, we could write this top one as x minus 2. So that means these two are going to cancel out. And I've got negative x over x plus 1. And then we also have to write where it's undefined. X cannot equal. For that, I need to look at the one before I canceled. So this one can't have a 2, and this one can't have a negative 1. Now there is a shortcut. Anytime you have two factors where they're exactly opposite of each other, so notice here that this 2 is positive, this 2 has a minus in front, this x has a negative, this one's positive, so they're exactly opposite from each other. What you can do is you can cancel them and put a negative out front. So then I would have negative x over x plus 1. See, that's the same thing I got. Here I just I did it the long way. But it's okay with me if you just want to cancel them and put a negative out front. That's a shortcut, it saves time. So please practice these on your own. Okay, I see a GCF of 2. I'm going to factor out 5 minus and take that 2 out. And then I've got x minus 5. 5 minus x and x minus 5 are opposites of each other. So I'm going to do the shortcut. I'm going to cancel them out and put a negative out front. Hey, I'm just left with negative 2. But I have to also write where it's not equal. So x cannot equal positive 5. You look in the original. This next one, I see a GCF. Now, you know on this one, I have this negative out front. I'm going to go ahead and factor out the negative x. So I'm dividing this by a negative x, so I'm going to have a positive x left. I'm dividing this by negative x, I'm going to have a negative 3. And when I'm doing this, I always double check and distribute it in my head and make sure that I did it correctly and didn't mess up my negatives. Okay, on the bottom we could guess and check, but you know what? I think I'll do splitting the terms another time just to give you another look at that. Guessing and checking on this one would probably work pretty nicely. But let's practice splitting the terms. So 2 times 3 is 6. So I bring down the 2x squared. Two numbers that multiply to negative 7 and add to 6 are 7 and 1. And it's going to have to be positive 7x and minus 1x. And then bring down the plus 3. Here I can only factor out an x. I'm going to be left with 2x plus 7. Here I need to factor out, oh whoa, did I make a mistake because this isn't working? 6, two numbers that multiply to 6. Oh, I did it backwards. I wondered if I was doing it weird. Oh my goodness. I feel really silly now, I'm so sorry. Okay, that's okay though, that happens. You make mistakes and it's not going to work, so I'm going to back up. I did this wrong. Bring down the 2x squared. You want two numbers that multiply to 6 and add to negative 7. So that's going to be 6 and 1, and they're both going to be negative. That's to multiply to 6 and add to negative 7. Negative 6 and negative 1 will do the trick. Okay, now we're going to factor out a GCF, which is 2x. Divide that by 2x and you're left with 3, with that minus there. And then here this negative always, whatever the sign is, it always comes down. So we're factoring out a negative 1, because that's all we have there. So that's going to be x. And you're dividing this by a negative, so it's actually x minus 3. And then you're left with x minus 3, parenthesis, and then the 2x minus 1 there. Okay, I'll erase this. And put in our result, x minus 3 and 2x minus 1. Get this out of the way. Great, so the x minus 3's are going to cancel. And we're left with negative x on top and 2x minus 1 on bottom. And then I have to say x cannot equal. If I look in the original, it can't be a 3. And then I have to make this equal to 0. Hopefully you're getting to where you can actually do these in your head, but if not, I'll demonstrate what I'm doing. I'm going to add 1 to both sides and then divide by 2. So 1/2. Right, now we're going to multiply. So this is example 3. Okay, we have all these things here. I'm going to write it bigger. And essentially we have 3 things we need to work with. We have all the numbers, so the coefficients. We have the x's and we have the y's. Now the y's, I'm noticing we just have y to the fifth over y squared. So those are going to be fairly simple to simplify. Y squared and y to the fifth over y squared is y to the third. So that'll cancel out and that'll become y to the third. I'm going to go to a different color. I think that'll be better. 2, so anything, you could kind of think of this as one big long division bar. Anything on top can be canceled with anything on bottom. So this 2 and 8 can be canceled. 2 goes into 2 once. 2 goes into 8 4 times. 3 and 15 can reduce. 3 goes into 3 once. 3 goes into 15 5 times. The x squareds will cancel. X squared divided by itself is gone, so we can knock those out of there. I've got x to the fourth over x cubed. So 4 minus 3 is 1. That means I have x to the 1 on top. That means that's completely gone. And that cancels out to a 1. And I do believe that's all we can do. Let's see what we end up with here. So we've got x to the 1 here. We've got y to the third. All of that on bottom became 1. We still have a times 5 here. That lift disappeared. That's just 1. 4. And those canceled out. And then we usually write it as, we put the coefficients out front. 5x y to the third over 4. And assume that all expressions are defined, so we don't have to worry about that last part. This one is polynomials, so we get to factor again. X plus 2. The other thing you can do, what I like to do, because they're being multiplied together, you can think of it as one big division bar. So on the top I've got x plus 2. Down here I can factor out a 3. That's going to give me 3 times x plus 4. This x plus 4 cannot be reduced or factored. Oh, I'm going to sneeze. And then x squared minus 4. Sorry. X squared minus 4, remember that one? That's the difference of squares. That's the a squared minus b squared pattern, which is a plus b times a minus b. Hopefully you're getting to where you can recognize that. So that means it's going to be, you take the square root of x squared, which is x. You take the square root of 4, which is 2, and then you put 1 plus and 1 minus. The x plus 2's will cancel. The x plus 4's will cancel. And what are we left with on top? There is something there. There's a 1. So I still have a 1 on top, and there's a 3 down there, and there's still an x minus 2 down there. And we're multiplying those together. You can just leave it like that. You don't have to distribute the 3. Here is a chart telling you, or listing, some of the, what the ways are. So we factored, then we divided, which is canceling, and then multiplied. I did the 3 times that. Be sure the numerator and denominator have no common factors other than 1. So yeah, that means it's completely reduced. These are ones to do on your own. So I'm going to write them bigger. I like to get the constants dealt with. I noticed 2 will go into 20 10 times. And then 10 and 15 will reduce. Divide each of them by 5. And now all the numbers have been reduced as much as possible. On top I have, so there's an x here and here, so these cancel out. Oh, I should have done these in a different color. Keep forgetting. And then x to the 7th over x to the 4th. You do 7 minus 4, which is 3. So x to the 3rd on top. So I have a 2 and an x to the 3rd on top. What you can do too is you can cancel these and write x to the 3rd. 2x to the 3rd on top. And there's still a 3 down here. And everything else got canceled. Oh boy, we got lots of factoring to do on this one. So I can see a 10 can come out of that one. I'm going to make it one big division bar. I've got an x plus 3. This is going to be 2 sets of parentheses. 4 and 2, negative 4 and negative 2. And then we can factor out a 5. And we get that. Then we get to cancel. That's the fun part. The x minus 4's are gone. The x plus 3's are gone. 5 will go into 10 twice, and we end up with 2 on top and x minus 2 on bottom. And they say assume all expressions are defined, so they're not asking us to say where it's undefined. Sorry, I always feel clogged up a little. Now we're going to divide. And just like with fractions, you know how when we divide this we would multiply by the reciprocal? Well, we have to do the same thing with polynomials. So on this particular problem, the first fraction will stay the way it is. And then we have to flip the second one and multiply. This time I'll go to a new color. Let's see, let's do the, 9s will cancel completely. 4 will go into 16 4 times. The x to the third over x squared will become x to the 1 on top, because I'm doing 3 minus 2, which is 1. So that becomes 1. And y to the fifth over y is y to the fourth on top. So I'm left with, on the top, I've got x, I've got y to the fourth. On bottom, I am left with a 4. Okay. Then the next one, okay, let's go to the next slide. Or I was gonna, yeah, I'm just kind of seeing here. Great. Now, oh boy, look at this one. Lots of factoring here, but they don't look like they're going to be too bad, because there aren't any coefficients out in front, so that shouldn't be too bad. So on this first one, I have a GCF of x to the third, dividing out the x to the third on top. Ooh, x squared minus 4. Notice that can be factored again. So I'm going to go ahead and do that. Well, we could do it on the next step, I guess. X squared minus x minus 2, that's going to factor to 2 sets. That's going to be negative 2 and positive 1. At this point, I'm not explaining how to factor each one, because we've done that before and it takes up too much time on the video. Now we have to flip and multiply. So the x squared minus 1 is going to come up on top. And instead of writing it up there, I'm going to factor it also. It's a difference of squares. So you take this, it's going to be xx and 1 and a plus and a minus. And then this part here will go down below because it flipped. And I'm also going to factor out the GCF, which is x to the third. So I'm going to be left with x squared minus x minus 2. Now I can see that there's some more factoring that we need to do before I can cancel. Actually, I can do a little canceling, so x plus 1s will cancel right off. Actually, these I'll go to a different color. I like pink. These are going to go too. Let's do similar. Red. Ooh, that's not going to look very good. I don't know, green. Okay. Now we need to factor x squared minus 4. That's a difference of squares. So x plus 2, x minus 2. X minus 2 still on bottom. Times this x minus 1 on top. And this part needs to factor 2 sets parentheses. That's going to be negative 2 and positive 1. Now I can cancel that one and that one. And is there anything else? X minus 1, x plus 2. Okay, I don't see anything else. So then at the very end, just multiply your numerators together. X plus 2 times x minus 1. And in the denominators, you can write it like that. And again, it's assuming all expressions are defined. I was going to look in the book and see if they actually distribute these out or if they leave them. I kind of like to leave them, but I'm just curious to see. I'm going to check and see what the book did. Example 4, part B. Oh, they said or. So, yeah, I'm happy with them the way they are. You could just leave them like that. And, yep, good. Here are 2 to do on your own. X squared over 4, we have to flip and multiply. New color. Okay, I see 4 will go in there once and in there 3 times. I see the x squared over the x to the fourth, so that's going to cancel, and you're going to have two x's on bottom. So the x squared, that's going to become x squared on bottom, because think 4 minus 2, but the one with the more x's is where the final result's going to be. So this one on bottom has more x's, so once you simplify, you're going to end up with the leftover x's are going to be down here on the bottom. And then y squared over y is just y on top. So that cancels out. You're left with the y. So you're left with 3y on top, and oh gosh, that was x squared, and everything else is gone. Okay, dokes. Now on this one we have to do some factoring. Oh, do I want to guess? Oh, I think I'll do splitting the terms over here on this side. Negative 8, bring down the 2x squared. Two numbers that multiply to negative 8 and add to negative 7 are negative 8x and positive 1x. And then bring down the negative 4. I'm going kind of fast because you've already done this on your own, hopefully. 2x will come out. Positive 1 will come out. That means that stays the same. We have an x minus 4 in common, and then we're left with 2x plus 1. So I've got x minus 4, 2x plus 1, and then this is a difference of squares, x plus 3 times x minus 3. We're multiplying, so we have, or dividing, so we have to flip and multiply. So this big thing is going to come up here on top. I'm going to come aside and work with it. Well, yeah, I think I'll work with it down here and then put the result up there to save space. I noticed that there's a 4 that's a GCF, so let's take that out. Dividing everything by 4. And I'm going to try guessing and checking this. In fact, I wonder if we didn't do this one earlier. It looks familiar. If we did, you could look back in your notes and see what it was. I'm going to just guess and check. I think that'll be faster than splitting the terms. I know that one of these are going to both have to be negative because they have to multiply to a positive and add to a negative. Thinking about the 3 and the 1, let's see how that works. So to check that, that's going to be 2x squared minus 6x minus x plus 3. And that's going to add to negative 7x. So that's going to do the job. So all of this will come up here. I chose to guess and check because 2 only has factors of 2 and 1, and 3 only has factors of 3 and 1, so there weren't that many options, so I thought that would be quick to just guess and check. And then this 4x squared minus 1 has to come down here. And do you recognize that that's a difference of squares? So the square root of 4x squared is 2x, and the square root of 1 is 1, and 1's a plus and 1's a minus. Hopefully the more you do these, you start to get fast at them. Now I have to cancel, so those go. X minus 3's, 2x minus 1's, and that's all I see. So there's a 4 times an x minus 4 on top, and there is an x plus 3 on bottom. And that's all we got. And we are assuming they're defined everywhere, so that is nice. Saves a little bit of work. Okay, we're on the last objective, I do believe. Oh. Yeah, I was going to show you guys something too on the calculator. I forgot to do that. Well, we can go back to that. Wow, time's going fast too. This is a long section once again. So solving, what you have to do on these is you need to simplify it first. So right away I see I've got a difference of squares there that I can factor. Bring along. I know I'm going kind of fast because I'm kind of running out of time. So I just factored the top, brought down the bottom. These cancel out. So I'm left with x minus 3 equals 7. So I add 3 to both sides, and I get 10 as my answer. And then we do need to check these, and if you want to check them on your calculator, that's okay too. So I think I could probably do it quick enough though. 10 squared is 100, minus 9 is 91. And then 10 plus 3 is 13. 91 divided by 13. That's not something I do very often. Does that equal 7? Let's hope so. Let me get my calculator going. Oops, that's not what I wanted. I want to clear. 91 divided by 13 is 7. It checks. Great. Okay, this next one, we're going to have to factor the top. We've got x plus 4 and x minus 1. That's going to do the job. X minus 1 on bottom equals 5. I apologize if I'm going too fast. These cancel out. X plus 4 equals 5. Subtract 4 from both sides. X equals 1. Check. Okay, I could probably do this in our head because it's 1. So 1 squared is 1 plus 3 times 1 minus 4 all over 1 minus 1. That's going to cause a problem. That equals 0. We cannot have a 0 in the denominator. You know what that means? This is not going to work, and there is no solution to this. Let's check that out on the calculator, see what that looks like by graphing them. So what I'm going to do is graph this side here, and then so I'm going to put the left side in y1 and the right side in y2, and since there's no solution, I'm anticipating that they're never going to intersect. When you're typing this in, you need parentheses around the entire numerator, x squared. Please follow along with me on this. It's important that you're able to do this on your own as well. Divided by parenthesis x minus 1. You have to put parentheses around your numerator and your denominator. Or at least it's a good practice. You don't really actually need them on the numerator, but, well, actually you do. Just put them in there. Make sure you do them, and then if you do them, you know you'll always get it right. And then divided by 5, equals 5. Let's see if it'll show up on a Zoom 6. What? Y equals x squared. Something isn't right. X squared plus 3x minus 4, x minus 1 equals 5. Why am I getting a line? That's really weird. Oh, I know why. Okay, the reason is, yeah, these are lines. That's right. The reason it's a line, by the way, this whole thing, even though it looks really complicated, you know what? It's really just the line x plus 4, because when we factored it and canceled, we were left with x plus 4. So we've got x plus 4 crossing 5. It looks like there's an intersection right there, doesn't it? So let's check it out. Second trace, intersect, enter, enter, enter. And there's an intersection at 1, 5. But the problem is, this original function is not defined at 1. It's called a hole. There's actually a hole there. And you can see it in the table right here. When x is 1, y sub 1, or y, the first equation has an error. So you may not have anticipated that happening. And this is actually our last slide, so please do these on your own, and then I'm going to do them here real quick for you, as quick as I can without going too fast. X, this is going to be positive 4 and negative 3. X plus 4 equals negative 7. Those are going to cancel. X minus 3 equals negative 7. Add 3 to both sides, and I'm going to get x equals negative 4. Check that. Right away, of course, this time I'm looking, is it going to work in the denominator? No, it is not going to work. So again, we have no solution. Oh, I forgot to write that on the other one. So if you want to take time and go back and graph this, graph these, make it equal to negative 7, and if you try to find the intersection, you're going to find that it intersects at negative 4, but the problem is this original one is not defined at negative 4. Let's do this next one. 2x plus 3 times 2x minus 3 over 2x plus 3 equals 5. This was a difference of squares. Those cancel. 2x minus 3 equals 5. We're going to add 3 to both sides, so I'm going to get 8 over there. I'm going to divide both sides by 2 and get x equals 4. I see that I can put 4 in here and here. Let's just do a graphical check this time. Clear, clear. So I'm going to put this one in y1 and this one in y2 and see if they cross at 4. So again, I need parentheses around my 4x squared minus 9 divided by parenthesis 2x plus 3. And then in y2, 5. Let's see if we graph it. Okay, great. You can see them crossing at 4. Let's double check and make sure we don't have any holes there. Enter, enter, enter. 4, 5. Well, I know there's no holes because if you plug 4 in here, you're not going to get 0. So it checks they cross at x equals 4. I wanted to go back and I forgot to show, let me see, the calculator, example 2. Oh. I was going to show you on the calculator why it's undefined at 2 and negative 1. So y equals clear, clear. What I'm going to do is type the function in, the original one in, because that's the one we're interested in. 2x minus x squared close divided by parenthesis x squared minus x minus 2 close graph. And we're going to check values at 2 and negative 1 in the table because that's the easiest. And if I go to, let's look at negative 1, notice I have an error at negative 1 and I also have an error at 2. So that confirms that it doesn't exist at both 2 and negative 1. And we'll see you next time.